So now that we've kind of talked about the completion stage methods, let's turn our attention to another type of method that's defined in CompletableFuture. And these are the exception methods. These are methods for handling runtime exceptions. And we'll break this up into two parts. The first part, we'll talk about how you can handle runtime exceptions, and I think the second part gives some examples of how to do it. As you can see here, there's not a whole lot of exception methods. I think there's about 6 or so it's not the most, doesn't cover the bulk of the processing that's available in the CompletableFuture API, but it's very useful to know how these things work. So first, let's take a look at the big picture. Exception handling is more complicated for asynchronous computations than for synchronous computations. And you can read more about this at the link below, but of course I'll explain it to you here. And if you have any questions, I'm happy to take them. So let's first think about how do you handle exceptions in the conventional way. If you have a synchronous code where you make method calls in the good old-fashioned way, two-way synchronous calls. So let's say we have method 1, which calls method 2, which calls method 3, which calls method 4. And let's say, for sake of argument, that method 4 is going to go ahead and throw an exception. It throws an IO exception. And the way that this works with synchronous calls is that the exception will propagate up the stack looking for an exception handler that can handle that particular exception. So the Java virtual machine or the Java runtime, the execution environment, searches up the call stack to find a suitable exception handler. And that could either be something that handles IO exception specifically, or it could be something that handles a more generic or more general type of exception, like exception or throwable. And let's say, for sake of argument, that method 1 catches the IO exception. So it'll propagate it back up, and either it'll catch it, or if it's not caught at all, it'll fall off the end of the run method in whatever thread that the exception occurred in, and then bad things will happen because you're not supposed to have exceptions percolate out of the calling scope of the thread in which they're created. So that's synchronous exception handling. What happens with asynchronous exception handling? Well, the thing that makes this more complicated is that asynchronous processing doesn't conform to the conventional call stack model. And that's because completion stage methods can be running in different worker threads than the thread that invoked them originally. In fact, that's pretty much always the case. And that's the point. You want to have these asynchronous computations running in other threads, in background threads, for example, coming out of the common fork join pool, rather than the thread that invoked the call in the first place. So that's the thing to remember. So therefore, we have a bunch of completion stage methods that are defined to handle runtime exceptions that occur asynchronously with respect to the original invocation of the method. And let's take a look at some of the nuances here. Here are the methods that are defined. We have when complete, and there's an async variant. There's a handle method and an async variant, and then there's an exceptionally method and an async variant that came along in a later version of Java. We'll talk about that later. So when complete, either sync or async, takes a by consumer and it returns a completable future with the result of the earlier stage, or it throws an exception. And what it does is it is very clever, and it'll handle the outcome of a stage, whether the result was correct, it was just a regular value because all went well, or whether an exception occurred. And you'll see how the by consumer is used to make that differentiation. The next method that's provided here is called handle, or handle async, and it takes a by function parameter and it returns a completable future with the result of applying the by function. And what that'll do is that'll handle the outcome of a stage and return a new value. Again, there's a differentiation there made between the normal processing, in which case you have a value, or an exception, in which case you get a chance to change to a different value and mask the exception. And then there's also another variant of exception handling called exceptionally, and this takes a function and it returns a completable future to type T. And when an exception occurs, the exception is replaced with a value that's returned from exceptionally. So this is another sort of way of masking exceptions by returning a default value. For example, if a divide by 0 exception is encountered, you might just return 0 rather than percolating the exception. All of these different exception handling methods help to make your programs more resilient by handling erroneous computations gracefully. So as is always the case with exception handling, you want to separate out the path for normal processing where all is well and it's a sunny day with a bright blue sky, unlike today, of course, from the situation where there's a storm and there's thunder and lightning and things come crashing down. That's a different path through the code. Java 12 added the exceptionally async method just because they wanted to be consistent. So that's the end of the quick overview of Java completable future features that deal with runtime exceptions. What we're going to do, of course, in part 2 is then walk through a bunch of examples to show how all these different features work.